In section 5.4, you saw the derivative and antiderivative of exponential function with base e that we denote by e to the x, right? And then we learned that the derivative of e to the x is e to the x, and antiderivative of e to the x dx is e to the x plus c, right? But exponential function is generally x in the exponent. So the base may be e or may be different from e, like 2 to the x, 3 to the x, 5 to the x, or any positive number base to the x. That is exponential function, okay? So if there is the base is different from e, like a to the x, what is the derivative or what is the antiderivative if the base is different from e? Okay, the base must be positive and then not equals to 1 to be exponential function. Okay, if base is a 1, then it will be 1, right? So if base is different from 1 but different from 1 and e, and if the base is positive number, then this is also an exponential function. Now, how do I find the derivative of this, and how do I find out the antiderivative of this? Okay, so what we do is, to find out the derivative of this, we want to change this function into base e. How do I do that? Okay, let us do that. Do you know from college algebra that if you have a to the x equals to y, do you know how to write this using a log? Is you write x equals to a log of y with base a, right? That's what you write, right? So log of y with base a. So let us do that thing. So log of y with base a equals to x. That's what we got, right? But do you also know the change of base formula? You can write this log with base a into log with base e, that is ln. You can write this using ln. How do I do that? It is ln y over ln a equals to x, right? Now let us multiply both sides by ln a. What do you get? Ln y. Ln is log base e, right? Equals to x times ln a, right? So y equals to x times ln a. Ln y equals to x times ln a. Now what is y? How do I get rid of ln? So write down e to the, because ln is log of y with base e. That's what it is, right? Now if you want to get rid of log from the left side, then how do you write? E to the right side. So y equals to e to the x times ln a. So what is our y though? Y is a to the x. So what we get is a to the x, which is equals to a to the x, right? Because that is equals to a. So a to the x can be written as e to the x ln a. That's what you got. You see that? So if there is a to the x, then you can write this using the base e. Why we want to write using base e? Because we know the formula to find out the derivative and antiderivative if the base is e, right? Like that. Okay, so that's why, because you know that the antiderivative, derivative of e to the u is how much? E to the u times u prime, right? That's what you do. So it is like e to the u now, right? A to the x can be written as e to the x times natural log of a. Now to find out the derivative of that, you can treat this as like e to the x times ln a, and then this is prime, right? Isn't that like u? This thing is like u. What is the derivative? E to the u, e to the x times ln a times u prime. U prime is the derivative of that. But natural log of a is a constant. So the derivative of this thing is just derivative of x is 1. So it is like ln a. Okay. So you see that if you want to write, because e to the x times ln a is same as a to the x. So you can write a to the x times ln a. That is the derivative here. Okay. That is the derivative. Okay. All right. So how do I find out the antiderivative then? So this can be written as e to the x times ln a and then dx, right? Now do you remember the formula that we used? If you have the integral of So integral of e to the u times u prime is e to the u, right? That's what the integral formula is, right? Or if you don't like that, let us take that this as u and then find out the, let us take to find out the integral, this is, let's say that is u. Set x times ln a equals to u. Now find out the derivative. So ln a times dx, because the derivative of x is 1, right? So equals to du over dx, but if you can write that as ln a times dx equals to du. So we don't have, what is the dx then? So dx will be 1 over ln a times du, right? So this integral can be written as e to the u times 1 over ln a times du. This ln a is constant because a is a constant number, so you can pull that out. So it is 1 over ln a and then integral of e to the u du. So 1 over ln a. What is the integral of e to the u? It is e to the u, right? So basically a plus c, right? So it is 1 over ln a times e to the, what is u? U is x ln a, right? X times ln a plus c. But if you want to write this more precise form, what is e to the x ln a? That is a to the x, right? It is like a to the x over ln a plus c. Okay, now you might think, how do I remember this formula? So the derivative of e to the u or e to the x is e to the x itself. The derivative of e to the x is e to the x itself. But if there is a derivative of a to the x, it is a to the x, that quantity, that function itself times natural log of the base. You see that? So it is like e to the x ln a, or which is same as a to the x times ln a times ln base. Now how about the integral? Integral of a to the x is a to the x divided by ln a. Here it was times ln a. Here it is divide ln a plus c. That's how you find out that's the formula for the integral of a to the x. Okay, guys? All right. Let us do some examples from the book. Okay. So the question number, this is question number 39 from the book. Okay, you want to find out the derivative of dy over dx of y equals to 4 to the x. What do you think? So the answer is y prime equals to, it says a to the x. It is like a to the x, right? So a to the x times ln the base, right? ln 4. That's it. Okay. Let us do number 41. Okay, number 41. Number 41. So you know what? Basically, if you want to find out the derivative of a to the u, you can think of, let me show you the formula that the formula sheet for the derivative. That formula sheet has the derivative table has the derivative of, you see that? A to the u, the derivative of a to the u. What is the derivative of a to the u? Is a to the u times ln a and then times u prime, right? So if you want to put that formula here, let me write down that too. So if there is a to the x, then a to the x times ln a. But if there is like, let me use different color. If there is a to the u prime, then the formula is a to the u times ln a times u prime. Okay, if there is a to the u. Okay, but if there is a to the u integral, then you will have to do the u substitution there. Okay, so we cannot just say it directly. I mean, we may be able to, but it will require some of the understanding. So we will talk about that a little later. Okay, so let us do question number 41. 41 is y equals to 5 to the negative 4x. Negative 4x. How do I do that? It is like a to the u. A to the u. The derivative of that is y prime, then y prime equals to a to the u is 5 to the negative 4x times ln a is ln 5 times u prime. What is the derivative of negative 4x? Is negative 4, right? So the final answer is negative 4 ln 5, because that's the number, times 5 to the negative 4x. You can do like this. Okay, guys? All right. So let us do some more problem. So what I want to do is I want to do number number 45. Okay, number 45 is y equals to negative 2t square over 8 to the t. Find dy over dt, because there is no x, so there is no point of saying like dy over dx. It is dy over dt. Okay, so to find out the derivative of negative twice t squared over 8 to the t, we need to use the quotient rule. So what is the quotient rule? What is the derivative of f over g prime? That is, it is f prime times g minus f times g prime over g squared, right? Let us do that. So y prime is equals to negative 4t, because the derivative of negative 2t squared is negative 4t times g is 8 to the t minus f is negative twice t squared times g prime. So what do you think the derivative of 8 to the t? It is 8 to the t times ln 8, right? It is like, you see that? 8 to the x times ln a. It's the same thing. Divide by 8 to the t whole square, right? How much is that? That is negative 4t 8 to the t plus, how much is that? 2t square y plus, because double negative there, right? 2t square ln 8 and then 8 to the t, right? We'll take 8 to the t out because that's the common in the numerator, and this is like 8 to the t times 8 to the t, right? Let us write down. Why did I write that? Because I want to cancel one of that 8 to the t. So what do you get? Let me take 8 to the t out. I mean, I can take 2t and then like that. So I can write 2t and then 8 to the t out. How much left? Negative 2 and then plus there is 1t and then ln 8, right? Divide by 8 to the t times 8 to the t. Now cancel out that 8 to the t because that's division, right? So what is the final answer then? The final answer will be y prime equals to twice t and then t ln 8 minus 2 divided by 8 to the t. That is the final answer. Okay, so there may be multiple ways to do this. You can use natural log on both sides and then do that way. That is fine. Okay, but that's the easiest way to do that. Okay, so we will see more examples in the next video, and then we will work on the how do I find the integral of the exponential function with base different from a in the next video. Okay guys, thank you.